Today we're going to talk about the wind in the atmosphere, also known as global winds. So what causes winds? Well, wind is the movement of air caused by differences in air pressure. So it's when you have a difference in a high pressure and a low pressure is when the wind is actually created. So winds that blow steadily from specific directions are known as global winds. And they're known as that because they are globally around the entire world. And within those ranges of latitudes, they are always known as the same type of wind. So warm air rises at the equator and it falls at the poles. Okay? And the movement of air between the equator and the poles produces what's known as the global winds or the global wind belts. Now, they are triggered and in part working with the Coriolis effect. And the way the Earth's rotation makes the winds curve or move in a curved pattern is known and caused because of the Coriolis effect. So these are the wind belts. They're done in 30-degree latitude increments. So 0 degrees is the equator, and we go 0 to 30, 30 to 60, and 60 to 90, which is the North Pole, or 90 south, which is the South Pole. So the first wind belt we'll talk about is the polar easterlies. And the polar easterlies are found and blowing between the poles, North Pole and South Pole, and 60 degrees latitude. So when we're talking about these wind belts, we're always talking about north and south. So there's two polar easterlies. They are the reason we have cold air over the United States producing snow in the winter. That cold air comes from the poles coming down over northern Canada. The second set of winds are the westerlies. Sometimes you may even hear them considered to be called the prevailing westerlies. They are the same winds, and they are blowing between the latitudes of 30 degrees and 60 degrees north and south. In the north, they carry moist air over the United States, often producing rain in any of the months. And then we have the trade winds. The trade winds blow between 0 degrees or the equator and 30 degrees north and 30 degrees south. Sailors relied on them when they were sailing from Europe to America. That's one of the reasons they're known as the trade winds, because they often were using them to help them trade. The doldrums are an area that's calm, found around the equator. And it's calm because there's no wind there because of a low pressure area. Doldrums actually means dull or sluggish. So the boats or the ships that were caught in this area were often considered to be dull or sluggish in their motion. And that's because of that low pressure, meaning no wind. And then we have the horse latitudes. At 30 degrees north and 30 degrees south, the air stops and sinks. This is a problem when you have ships trying to cross over these areas in the oceans. So this area was named for the ships that basically were carrying horses with them from the European continent over to the New World. So from Europe to America, often the ships would stall out about 30 degrees. And so sailors were forced to choose how they could lighten their load, because if the wind stops and there's no motion, the ship, which is wind powered, no motors were available at the time, it doesn't have a way to go. So they were trying to be smart about what they would throw off. They couldn't throw off their food, they couldn't throw off their people, and they couldn't throw off their ammunition or weapons. So they would throw off the horses, and so that became known as the horse latitudes, because many horses were pushed to their death and basically forced to allow to lighten the load. Because one horse is about a ton, which is 2,000 pounds. So they were able to conserve other things to be able to continue their trip along the way. Now, jet streams are belts of high-speed winds that are very high up in the atmosphere. There are two main jet streams, the polar jet stream, which is seen here in blue, and the subtropical jet stream, which is the red. And they both blow from west to east at speeds of 200 to 400 kilometers per hour. They are above the surface of the earth. That's why you do not feel them. However, when you fly, they're in that upper part of the troposphere. Planes are going to encounter these jet streams. So it helps a plane when it's flying from the west to the east, because it's going to be blowing with the wind, meaning it's going to speed you up. But it goes against the planes when you're traveling from east to west, and it slows you down. It would be kind of like trying to go up a down escalator. Then we have something called the local winds. Now, local winds are winds that are locally going to be based on the environment around them. So local winds are going to blow over short distances. Global winds blow all the way around the world. Local winds blow in a small area. They are going to be caused by the unequal heating of Earth's surface within that particular area. And there are two main winds that work together. There are four winds, but two and two. You have a sea breeze and a land breeze, and then you have a mountain breeze and a valley breeze. Let me explain what I mean by that. So in the morning at the beach, this is the ocean, this is the land. The land is going to heat up much faster than water, and it heats up because of that solar radiation. We know that the sun heats this up much quicker. So eventually that land will heat up, and it's going to cause that warmth to rise up. When it does, it creates a low pressure system. We know that all heat rises, cool sinks, and so we get a convection current. So in this case, it's going to force that heat out over the water and push the cool over the water down. This is going to be your high pressure. And then the winds are going to blow from the water, from the high pressure to the land. That's why you have what's known as a sea breeze in the morning. A great way to remember this is you quote, blow to the low. So you're blowing towards the low pressure. Also a great way to remember this, the name tells you where the breeze begins. So a sea breeze starts and blows from the sea to the land. Just like if you were to heat up your stove, this would represent the stove. It heats up immediately. It's going to take very little time to get warm once the sun is out. Once I turn the stove on, it heats up quickly. This is going to represent your pot of boiling water. I can leave the stove on for 2 or 3 minutes and the water is not boiling yet. So the water is going to take much more time to heat up. So this is in the morning. In the evening, you have the opposite. Because just like if I take that pot off the stove, or if I turn the stove off, the stove cools down quickly. So the land's going to cool down quickly. But the water, if I take that boiling water off the stove, 10 minutes go by, that water's still warm. It takes much longer to cool down. So land's going to cool very much faster than the water. The cool air is then going to fall over the land, which creates your high pressure. And it's going to force that cool air down and to go out towards the sea, from the land to the sea. The warmth from the sea is going to rise, creating that circulation pattern and spread out towards the land. So the winds move from the land to the water, from the land, from the high to the low. So we are blowing to the low in the evening. Now, in the daytime, in a valley, you will have the heating occurring as well. So the sun warms up on the mountain slopes, and the hot breeze blows from the valley, which is down here, up the mountain as the hot air rises. So basically, it's blowing from high pressure to low pressure, okay? So it blows out of the valley. The hot air rises from the valley, creating the valley breeze. When at night, that's the opposite. The air on the mountain is going to cool down, and it's going to sink. So it's going to go from the high pressure here at the top all the way down, creating the mountain breeze where it's cooler from the mountains blowing down. The cool air falls, creating the breeze. Here's another way to look at it. The hot air rises from the valley, creating a valley breeze. The valley out and creates that circulation pattern. At night, the cool air is going to fall from the mountain down into the mountains, into the base of the valley, creating the mountain breeze. Again, it starts where its name is from. It starts in the valley and it blows up. It starts on the mountain and it blows down. Okay? They are opposites, but they work together.